So whole circuit would be the equivalent resistance here, and we can certainly figure that out. We've got our two 16s that act like an 8. That 8 is in series with the 2, so our EQ is 10 ohms. We have a whole circuit voltage of 50 volts, and that means we can do the math here and figure out that this is 5 amps. Now, this resistor here, 2 ohms, this is a series resistor, so it will have the same current as that one. These guys may have different currents, but let's use this to find the voltage. 2 times 5 is 10. This resistor will dissipate 10 volts. That leaves 40 behind for these guys, so we can now figure out using logic that these guys are going to dissipate the remainder, which is 40 volts. And working backwards, we get our 2.5 amps and our 2.5 amps. So you're using a lot of Ohm's law to kind of fill in missing things on this table. Also, we can figure out that 5 times 10 is 50 watts dissipated by the 2 ohm resistor, and 2.5 times 40, which is 100 watts dissipated by each of the 16 ohm resistors. Now, just for fun, 5 times 50 is 250, and that is indeed what the sum of these things would be. These don't necessarily add up because you notice here we have multiple things that have 40 volts. So we don't add these two together because the 40 volts is dissipated when you go this way or when you go this way. So the parallel nature of this thing makes it so you cannot add down these columns the way you would want to. Anyway, we got many of the same results using kind of a slightly different logic. This may be the kind of thing that excites you and works for you. I personally prefer the bootstrapping method, and as you get good at this, you can actually do some of this stuff in your head. So let's have a lash at a rather complicated circuit. This one has some series, some parallel, and I've drawn the parallel in the old-fashioned way. And here we have a parallel that's 3 things in parallel, and I just want to remind you that our formula for equivalent resistance in parallel is 1 over R1 plus 1 over R2 plus 1 over R3 if you got one, and then you have to invert that whole thing. Okay, so in the bootstrapping method, I see that what we need to do here is we need to replace this with a circuit that still has a 100 volt battery, but that these 220s up here have been replaced with a single resistor, and these 3 down here have been replaced with a single resistor, and we'll leave the bottom resistor unmodified at the moment. So 2 20s in parallel, 1 over 20 plus 1 over 20 is 2 over 20. Flip it over, you got 20 over 2. That's going to be 10 ohms. These 3, but we're going to have to work a little harder to get this. Let's do it with the calculator here. We'll do it all clear. We're going to have a 30, 1 over, plus a 20, 1 over, plus a 60 and 1 over, hit the equal sign. We got 0.01, but we're not done yet. We have to 1 over that answer, and we get 10. So these, indeed, are another 10 ohm resistor, and this is a 30 ohm resistor. This is a 100 volt battery, and that means we can draw one more circuit, which has the 100 volt battery, and one resistor. 10 plus 10 plus 30 is 50 ohms. A lot of my students, after they've been doing this technique, when they get to a pure series circuit, they stop and they do all their math here because you can figure out the current that flows out of the battery, which is the current through each of these. You don't have to draw the extra one. But again, we're doing training wheels right now. So let's do it. The current that comes out of the battery is going to be the voltage over the resistance, which is going to be 100 over 50, which is going to be 2 amps. So there's 2 amps of current going through this. That would necessarily mean that this thing is dissipating 100 volts, and that checks out. Okay, now this current comes back over here for all of these guys. So we have 2 amps here, 2 amps here, and 2 amps here. And now we can find our voltages. 2 times 10 is 20 volts dissipated here. 2 times 10 is 20 volts dissipated here, and 2 times 30 is 60 volts dissipated here. 20 plus 20 plus 60 adds back up to 100. Happy birthday. These statistics here for this resistor are true on the original circuit, so we can fill them in right away. and we're done. Coming back into these parallel combinations, we're going to bring our voltage back. So let's get the blue pen, 20 volts. So this is going to dissipate 20 volts. This is going to separately dissipate 20 volts. And this will separately dissipate 20 volts. Also, this 20 volts comes back here. 20 volts, 20 volts. And now we can find our currents. Our currents. Okay, let's see. Current is going to be voltage divided by resistance. 20 divided by 6 is going to be a third. So that's 0.33 as far as I know. 20 divided by 20 is going to be 1 amp. And 20 divided by 30 is going to be 0.66. So together these add back up is what I was trying to say. Add back up to 2, which is our original current. Here we each get 1 amp, and that we realize that's an even split of the 2 amps that are coming out of here. So all is right with the world. We were able to solve the crap out of this circuit, even though it looks rather daunting. Okay, I'm putting this up.